at physics from the general perspective, from the ordinary meaning, and then what it deals with, what physics is all about. Physics is the study of physical quantities, right? So we can say the study of what? Physical quantities. And is the study of measurement. Physics is the study of measurement. So we take note of these key words. So physics is the study of measurement. Everything in physics has something to do with measurement. You want to make a table, the carpenter has to carry out what we call measurement of the length, the width, the height of the legs and everything. So they have to carry out measurement. You want to make clothes, the fashion designer has to carry out measurement in order to design the clothes. If you want to make a computer, they have to know what screen size and so all things you're making, you have to measure. You have to make a car, you have to carry out measurement. So physics is the science that deals with the study of measurement. So we can simply call physics a science that deals with what? The study of measurement. Science that deals with the study of what? Measurement. So we take that first. We can also say physics is the science that deals with the study of matter and energy. Chemistry is the science that deals with the study of matter only. But physics is the science that deals with the study of matter and energy. So you see, with another definition of physics is the science that deals with the study of matter and energy. So a second definition. So first definition, we say physics is the science that deals with the study of measurement. It's the science that deals with the study of measurement. So I'm only giving the key words, okay? The science that deals with the study of measurement, and again is the science that deals with the study of matter and energy. We also say physics is science that deals with the study of physical quantities. So another way of defining physics, we say it's the science that deals with the study of physical quantities. The science that deals with the study of physical quantities. So we're going to talk a lot about physical quantities because these physical quantities, they are like parameters. They are like parameters that you deal with when you're studying physics. Okay? They are like parameters that you measure. They are like parameters that you measure. They are like parameters that you deal with. They are like parameters that you take into cognizance when you are studying these subjects. Okay? So physics is the science that deals with this aspect. Now we're going to do a mind map. We're going to do a mind map of physics. I'll do it briefly. We'll do a mind map before we take this subheading, physical quantities, and we'll deal with the basic physical quantity and derived physical quantity. So we define physics as the science. See, when you are defining the subject, you say it's a science, right? Physics is a science. Chemistry is a science. Biology is a science. Physics is a science that deal with the study of measurement. Okay, so the first part to write it is easy, so that's why I'm not writing it. The science that deals with the study of measurement. The second definition of physics is the science that deals with the study of matter and energy. So even if you say this, you're still in order. And then the third definition of physics is the science that deals with the study of physical quantity. Now let's do a mind map. If I have the subject here, physics, a mind map of this subject. What are the branches or the things you need to do in physics? What are the areas of physics that we will be discussing? The area, the subject matter, the all-important aspect of physics that you need to master in order to be a scientist, a physicist, to be a physics scientist. You know, a physics scientist is a physicist, right? Is what? A physicist. Are you with me? A physics scientist is a physicist. Now let's take a look at some of the areas of physics. The first and very important area of physics, aspect of physics that you're going to be dealing with is called mechanics. It's called mechanics. This mechanics deals with motions, deals with distance, displacement, speed, velocity, okay? Speed, velocity, acceleration, force, pressure, all those first aspects of physics that you'll be studying from chapter 1, chapter 2, chapter 3, chapter 4. Those first aspects of physics that they are called mechanics. They are called mechanics. So these aspects are extensively used by those who will be in mechanical engineering. Those who are going to be studying mechanical engineering, they are extensively used, the mechanics. Okay, deals with force, force and object in motion, stationary objects, and all of these are called mechanics. So it's an aspect of physics. Another very important aspect of physics is electricity and magnetism. Another very important aspect of physics is called electricity and magnetism. It's called electricity and magnetism. It's a very important aspect of physics that will lead to the study of electrons, how electrons move, current, particles, electricity, electrostatic, magnetism, electromagnetic devices, and so on and so forth. This one leads to the study of electrical engineering, communication engineering, electrical communication engineering, computer engineering, and so on and so forth. Okay, so electricity and magnetism. It's another aspect of physics and magnetism. Okay, electricity and magnetism. Another aspect of physics. It's called electricity and magnetism. Is that okay? Magnetism. So another aspect of physics beside this one is thermophysics. Another aspect of physics is what? Thermophysics. The one that deals with heat. This one also more of mechanical. Okay? The thermophysics more of mechanical and so on and so forth. Any vibratory objects like aerospace, mechanical engineering, aerospace engineering. Okay? So here you study thermophysics. Here you deal with heat and temperature. Here you'll be studying heat, specific heat capacity, thermal capacity, latent heat of vaporization, and so on and so forth. Thermophysics. So here you deal with convection, conduction, convection, and radiation. Here you deal with thermometer and thermometric liquid. Okay. Here you learn how to use thermometer to measure temperature and the design of thermometers and thermometric liquids. Okay, so here you deal everything that has to do with heat transfer, and so on and so forth. Another aspect of physics, we're doing mind map or brain map. Another aspect of physics that you will go to be studying is called wave and light. Another aspect of physics that you will study is waves. Okay. This one is for also electrical engineering, electrical and electromagnetic engineering, electrical and electromechanical devices, and mechatronics, waves and light. So this one also has something to do with electrical engineering, telecommunication engineering, and so on and so forth. So you go to study optics, okay, optics, lights, focus, and so on and so forth. So it's waves and light. It's another aspect of physics. Okay, another aspect of physics we're going to do is space physics, astronomy and cosmology, the space physics. So I can simply write space physics, or I write astronomy and cosmology. Astronomy, maybe this is where they derive astro. This is Malaysia satellite television. Astronomy, meaning you're dealing with satellites. Astronomy and cosmology. Astronomy and cosmology. So here you study about the cosmos. You study about the universes. Cosmology. You study about the universes. It's simply called space physics. Cosmology. So you can simply call it space physics. Here you learn about the galaxy, Milky Way, the universes, the planets, and the launching satellites in the orbit, the different orbits where we can launch our satellites, and different satellites that can be launched. Satellite engineering. This one deals with satellite engineering in communication and telecommunication engineering. Okay, here you do more of communication engineering, signal processing, signal transmission, signal degradation, and all of that things. Okay, another aspect of physics beyond the space physics is medical physics. This medical physics, we don't do it for IGCSE, except very soon maybe they may introduce it. Is usually done in grade 12 or A level. Okay, this is called medical physics. Here you do a little bit of biology mixed with physics. A little bit of biology. Here you study the bicep, tricep, muscular bicep, tricep, and you do some calculation, force of your motions of your foot, and so on and so forth. Your arteries, you do the physical calculation, the force. So medical physics, here you learn about the physics of your biological body. Okay, it's called medical physics. Okay, those who are in medical line, they study this aspect of physics a lot. Okay, so we have medical physics. There are a lot. It's not finished. We have electronics. We have electronics. Another aspect of physics is electronics and logic gate. Electronics and logic gate. Electronics and logic gate. Okay. Then another one we've not mentioned is atomic physics and nuclear physics. Another very important one we need to mention. Another very important one we need to mention is atomic physics and atomic and nuclear physics. So this electronic and logic gate. Electronic and logic gate. Okay, electronics and logic gate. Logic gate is an aspect of physics. Okay, here you learn about electronic devices, amplifiers, you learn about IC, that's integrated circuits, you learn about transistors, you learn about the electronic circuitry, you learn about how your computer, what is inside your computer in the motherboard, what are the chips, the microchips, and the microelectronics, power electronics, all these things you learn. Logic gate, how to design alarm system, and all of these things. You learn from here the electronics and logic gate. There, remember I said there's another aspect of physics called the atomic and nuclear physics. Atomic and nuclear. So physics is one of the biggest subjects on the planet. Okay, it's one of the biggest and most interesting subjects on the planet. It's the mother of all the sciences. So here you have atomic, you'll be hearing atomic weapons. Here you learn how to make the nuclear weapons, atomic bombs, and so on and so forth. Atomic and nuclear weapons, and atomic and nuclear physics. So here you learn how to use nuclear to make electricity, radioactivity. You learn about radioactivity. You learn about the effect of radioactivity, and you learn about nuclear physics. Here you learn how to make atomic weapons, atomic bomb, missiles, and how to make nuclear bombs. Okay, nuclear bombs or nuclear weapons are, and are restricted. Only the G7 countries are allowed to, or equivalently have access to make all of this. So this aspect of physics you learn how to make. This one will lead to chemical engineering, and so on and so forth. Learning how to make bombs, how to make electrons, how to bombard, fire something to something, and cause chain reactions, and so on and so forth. So, okay, so we've done the mind map of physics. We say these are the different aspects of physics, basically, that you're going to study. Okay, when we talk about thermophysics here, you study temperature, heat, and thermometer, all of this. Okay, so this is the aspect of physics. Now, what are the careers in physics? If someone studies physics, what can he do in life? Careers in physics. Let's 1 minute go through the careers. What you can become if you study physics. Okay, what you can become if you study physics. What are the careers in physics? The subject, what can it give you? What will you be able to use this subject to do? Okay, sorry, this is R. Okay, I don't know, this system is laggy. Okay, Okay, what will you do, or what can you use physics to do? First of all, you'll be a scientist. The name of the scientist you become if you study physics is called physicist. So I write physicist down. Physicist means a physics scientist. If you study physics, you become a physics scientist. You'll be among they are looking for scientists everywhere in the world, right? Physicists. They are looking for scientists everywhere in the world, in New Zealand, Australia, all the developed countries. They're looking for scientists. UK, Germany, physicists. Germany, US, Canada, they're all looking for scientists. So if you're a scientist, they want to hire you. They want to hire you to work in their laboratories, research centers, universities, to discover new things, to help them join their team to discover new things. Because this world is now very competitive. You see, some countries, I don't want to mention their name, they are growing very fast. So the big countries are afraid of these countries that are rapidly growing fast. And they do a lot of scientific work, discovery. So the big countries are looking for big scientists in physics, in chemistry, in biology, to help shaping their development. Okay, so you can become a scientist. You can become a computer scientist with physics also. You can become a second scientist apart from being a physicist. You can become a computer scientist. You can become a computer scientist and computer engineer. Computer. Okay, let me first of all say scientist, computer scientist, and computer engineer if you study physics. You hear computer science, a lot of physics, you need a lot of physics to be able to study computer science. Okay, physics, computer scientist / engineer. I mean to write scientist. Computer scientist and computer engineer if you study physics. Computer engineer if you study physics. Then there are many engineers you become with physics. Here I cannot list all the engineering you can become, but I will mention them verbally. So I'll just write engineer down. You can become an engineer. Those who design and create, design and make and manufacture. You can become an engineer who invent things, who make computers, who make software, who make bridges, roads, houses, design. You can become an engineer / architect. Engineer and architect. So with physics, you can become an architect, can become an engineer, can become a scientist. So the architect. So with physics, you can become a lot of things. This engineering, we have to talk about what type of engineer. You can become a mechanical engineer with physics. You can become a chemical engineer with physics. You can become electrical engineer, electronics engineer. You can become computer engineer. You can become mechatronics engineer. You can become civil engineer. You can become building engineer. You can become construction and structural engineer. There are so many aspects of engineering you can become. You can become a software engineer. You can become a computer engineer. So many aspects, okay, of engineering. You can become aerospace engineer. You can become a marine engineer, meaning marine engineer means you design and build ship sailing in the water. Marine engineer. Aerospace and aviation engineering means you design and maintain aircraft engineering. So there are so many aspects of engineering. Okay, you can become a telecommunication engineer, network engineer, cyber security. So with this you can do so many things. And then with physics, another career, you can become a medical doctor. You can become a medical doctor if you study physics. Okay, if you want to be a medical doctor, it's not only biology and chemistry. You must also pass physics. You must also pass physics. They always say physics, because they know it requires a lot of medical devices. Medical doctor. You can also become a medical doctor. Okay, you can become a medical doctor if you are very good in physics. You You can become a medical doctor. Okay? You can become, and so on and so forth. So let's not too dwell on the careers you can be with physics. You can be a researcher, you can be an astronaut, okay? Especially astronaut. You can be an astronaut if you study physics. Because all those people go to space to launch a satellite or launch whatever, all those astronauts, they are physics experts. They are basically physics experts. So you can become an astronaut, okay, with physics, okay? Astronaut. With physics. Okay, you can become astronaut with physics and so on and so on. So there are many things you can become with physics. Now, since we say physics is the study, remember the definition we gave? We say physics is the study of measurement. So we want to talk about measurement and physical quantity. We want to talk about measurement of physical quantity. And we're going to look at this aspect, measurement of physical quantity, briefly. Okay, we want to look at the measurement of physical quantity. Measurement of physical quantity. So I abbreviate physical quantity. Physical, P-H-Y, okay? Physical quantity. Measurement of physical quantities. So I abbreviate both physical and I abbreviate both quantities. So let's take a look at the measurement of physical quantities. Remember, we say physics deals with the study of measurement. And measurement of what? Measurement of physical quantity. So since physics deals with the study of measurement of physical quantity, let's begin to look at it. Physical quantities are divided into two. We have the basic physical quantity. So this physical quantity are divided into two. So if I write physical quantity, I'm going to break it down into two. I'm going to break the physical quantity into two. Are you with me? So we're going to break the physical quantity into two. So physical quantity, they are divided into two. Physical quantity, they are divided into two. The first one is the basic physical quantity, which we're going to talk about. And the second one is called the derived physical quantity. So the first one is basic. So basic PQ, basic physical quantity, basic physical quantity. The second one is called the derived physical quantity, number 2. The second one is called the derived physical quantity. Derived physical quantity. Derived physical quantity. Okay, so derived physical quantity. Now, what is the meaning of basic physical quantity? A basic physical quantity is a physical quantity in physics that is formed, that is not formed from the combination of any other quantity. Okay? It's not formed from the combination of any other quantity. It's not made from other quantity coming together. Okay? They're not formed from, they are natural. So I'll just use the word natural. They are not formed from other quantity. Other quantity do not combine together to form them. They are natural. Other quantity do not combine to form them. They are natural. They are not made from other quantity. You know, some quantities, they are made by the combination of one or two or three other quantities to make them. So this basic one, they are natural. They are not formed from the combination. They are not formed from the combination. So I can't be writing such note, but at least you listen to what I'm saying. They are not formed from the combination of other quantity. They are natural. A good example is time. Time is not formed from other quantities. It's not made from. It's very natural. Okay, it's not made from the combination of one or two other quantities. Another example is mass, the mass of an object. The mass of an object is very basic. It's not made from the combination of other quantities. Another one is the length. The length of an object. The length of an object is very natural. It's not made from the combination of other quantities. So in physics, for IGCSE, there are 5. So I'm going to make a table to explain these 5. Because IGCSE, I'm going to give the physical quantity, their unit, and their unit symbol. So I make a table for these 5, but for A-level, there are 7. A-level, they just add 2 more. They add 2 more. So I write physical quantity, basic physical quantity. Okay, now we can say basic physical quantity, basic physical quantities, basic physical quantities. Then we talk about units. There are unit and unit symbols. Units and unit symbols. So I'll give you the whole 7 because for A-level grade 12 they add the other 2. So I'll just do it once in case you're doing it in another place, not with me, so you'll be able to you already know it, unit symbol. So there are 7 for A-level program or grade 12 program, but for IGCSE you just need the first 5 unit symbols. So the first one is length. The first basic physical quantity is length. The length is not formed from the combination of 2 or any other physical quantity. Length is not made from the combination of 2 or any other physical quantity. So what's the unit of length? Meter. The unit of length is a meter. Okay, let's hurry up. I finish physical quantity. We end this section. Another day we complete this chapter. Okay, chapter 1 we divide it to 2 sections. So length is meter, the standard unit. It doesn't mean you cannot use centimeter, but the international system of units, they adopt meter. Okay, so the unit symbol is small letter M, not capital M. Okay, so that's the first one. The second one is what? The second one is mass. The unit of mass is kilogram. The unit of mass is what? Kilogram. So the unit of mass is kilogram. And the unit symbol is kg. The unit symbol is kg. Small, everything small letter here. The third one is time. The third basic physical quantity. The third one is time. And the unit is seconds. Okay, minute is also a unit. Hour is a minute, is a unit. Even a day is a unit, but the unit symbol, but the standard one is seconds. And the unit symbol is small letter s. Okay, the fourth one is thermodynamic temperature. Thermodynamic temperature. So you can simply write temperature. Okay, thermodynamic temperature. Why I write thermodynamic? So that you know why the unit is not sensor, is Kelvin. Thermodynamic temperature. Okay, when you study higher physics or mechanics, you do a lot of thermodynamic physics. Thermodynamic temperature. But you can simply write temperature, okay? Like I said, you can just write temperature. You don't have to write thermodynamics. You can simply write temperature. Okay? So temperature. Number 4 is temperature. And the unit is Kelvin, not cents or degree Celsius. The unit is Kelvin because we are looking at thermodynamic temperature. Okay, so the unit is Kelvin and the symbol is K. Then the fifth one is electric current. Current that is flowing in circuits is the fifth basic physical quantity. So these are the 5 for IGCSE. Current. So you can write only current or you write electric current. It's up to you. Even if you write only current, you are still correct. If you write electric current, you are still correct. So you say electric current. Electric current. So we say electric current. Now we say in electric current, we say the unit is ampere. 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 And the symbol is capital letter A. The symbol is capital letter A. Now the sixth one, I told you if you know these 5, you're good for the IGCSE standard. The sixth one, which is from A level or grade 12 or foundation program, they will still give you the whole 7, okay? But then you already know them. So this sixth one is amount of a substance. Amount of a substance. This amount of a substance, the unit is mole. Mole is actually the amount of a substance. If you know the definition of mole in chemistry, amount of a substance, the unit is mole. The unit is mole. Mole. The unit symbol is mole, M-O-L, no E, just M-O-L as the symbol. The seventh one is called, either you say light intensity or luminous intensity. They are the same thing. Light intensity. So for easy ability, you can just write light intensity. If someone write luminous intensity, same thing. Light intensity. Intensity. It's a basic physical quantity. The amount of light that shines in a place is a basic physical quantity. So the unit is a candela. Candela. You must know all these 7 and their unit and their unit symbol. Candela, and the symbol is a CD. The symbol is CD. Candela, C-A-N-D-E-L-L-A. Candela, and the symbol is CD. So these are the 7 basic physical quantity. These are the 7 basic physical quantity. So for derived, we'll just talk it briefly and we end the class. Derived quantity are those quantities that are formed from the combination of 2 or more other quantities. So this one, they are not natural, meaning combined. So 2 or more other quantities will combine together to form this one. A good example is what? Speed. Combined, right? 2 or more physical quantities combine together to form a derived physical quantity. A good example is speed. For example, speed is distance over time. Speed is not natural. It's 2 things that combine together. It's equal to distance over time. The distance you cover over the time you take to cover the distance. That's speed. Is that okay? So let's begin to name them. Derived quantity. Velocity. Velocity is same as speed. Just the only difference is that velocity is a distance in a specified direction. It has a direction. It's a vector quantity. While speed is a scalar quantity, does not have a direction. So another derived quantity is acceleration. Acceleration is the rate of change of velocity or rate of change of speed. Meaning speed, change of speed over time taking, right? Acceleration. Acceleration. Acceleration is the rate of change of speed or rate of change of velocity. Another derived quantity, meaning this one is change of speed. Change means final minus initial. That's the meaning of change. Then when you say rate means divide by time. It means divide by. So this is the formula for acceleration, v minus u. So the acceleration is a. Acceleration is a. So a is equal to v minus u over t. Rate of change of velocity. Rate of change of speed or velocity. Anyone you use is okay. Then another derived quantity is force. Force is the product of mass and acceleration. Remember, force, F, is derived from what? From mass and acceleration. Mass is m, acceleration is a. So the product of mass and acceleration, that's the force. So it's a derived quantity, meaning you got it from other concept. Is that okay? Momentum, impulse, all of them, they are derived quantity. Momentum is the product of mass and velocity. The product of mass and velocity. Okay? So all these are derived quantity. Those things that you get, moment is the product of force and a perpendicular distance. Moment is the product of force and perpendicular distance. And then work done, force times distance, right? Work done is a derived quantity. And so on and so forth. Any quantity you can remember in physics, the majority of them fall under derived quantities. Okay, so that's for derived quantity. Now, before we end it, you've heard us mention, we mentioned scalar quantity and vector quantity. Okay, we end with that, scalar and vector. Let's end with this, scalar and vector. What's the meaning of scalar quantity? Scalar quantity, those quantity that has only magnitude but they do not have direction. Okay, they are called scalar. So let's put them in a tabular form and just do it once and for all. We start with their definition. Vector and scalar. So you hear this a lot in physics. Something is scalar means it only has a magnitude, size. Magnitude means size. Okay? Vector quantities. Okay, number one, we talk in terms of their definition. Scalar quantity has magnitude only. Please take note, this is IGCSE questions. Okay, magnitude only. Scalar quantity has those quantities. If you want to put it in a sentence, scalar quantity are those quantities that has only magnitude. So, but because I'm just putting in a phrase, I say magnitude only. Okay, so scalar quantity are those quantities that has only magnitude, right? Magnitude only. This one, the definition is that it has both magnitude and direction. Magnitude and direction. Magnitude and meaning it has two things. First, it has size. Magnitude means size, how big the something is. The value, it means value. It has magnitude. Then direction is where you are going. Magnitude, and this is my symbol for and direction. So not only does it have a value, it also has, it shows clearly where the object is going. That's the meaning of direction. Show clearly whether the object is going towards the north or south or east or west. It shows clearly, or moving a circular path. So it tells you the direction the object is going. A good example for magnitude only is e.g. speed. Speed is magnitude only, it does not have a direction. When you say, oh, a car moves 25 km per hour, that's just the speed. But when you say a car moves 25 km per hour due north, that's a velocity. That's a velocity. When you now say the speed and you give the direction, that's a vector quantity. It means it's a velocity. So when you say a car moves e.g. 25 km per hour, 25 km per hour, you only give the magnitude, the size, the speed of the object. That's what you told us. Only the speed at which the car is moving. 25 km per hour. But if I say 25 km per hour due south or due north, 25 km per hour east, 25 kilometers per hour east. So you are saying this car is moving towards the eastward, east of the world. The car is going this direction. It's going like this. The car is going like this. You've given the direction. It's going this eastward, because if you draw the four cardinal, right? If this is our four cardinal, this side is our west. No, this side is our east, sorry. Okay, I think the direction we were showing just now was wrong. This is our east. This is our north. This is the direction of the north. This is the west, right? This is the west. This is the south. Okay, so anytime you include the direction, or you say the object is moving in a circular path. Circular, if you say something is moving in a circle, it's also a direction. Okay, it's also a direction. If you measure any of these, you say, oh, it's moving. If you say towards east, means it's going this way. If you say west, then it's going this way. This way is west, this way. If the object is going to the left, or you use left and right, or up and down. If you say, oh, the car is moving upward. If you say the car is moving upward, that's a direction. If you say 25 kilometers upward, 25 kilometers downward, 25 kilometers, you are showing the direction. So it's a vector. Vector includes acceleration, velocity. So we list them. We give the example and then we end the class. We give the example. Another example for acceleration, for scalar quantity, is the distance. If you say, oh, it has a distance of this, distance does not show a direction. Distance means you can move anyhow from a place to place. You are not specifying the direction. Okay? But if you are saying displacement shows the direction. So, oh, he moves 25 kilometers east. That's a displacement. Okay? It's not just a distance. Displacement. That's a displacement. So displacement is a vector quantity. You need to know that this is always in IGCSE paper. Displacement is a vector quantity. Distance is a scalar quantity. Number 3, another example is speed. Okay, we already measured speed and velocity, right, for case 1. And distance and displacement. Energy is a scalar quantity. Energy does not tell a direction. Energy is a scalar quantity. You must know the quantities that are here. Another example of a scalar quantity, like your temperature. Temperature does not have a direction. Temperature is a scalar quantity. Okay, it's a scalar quantity. Pressure is a scalar quantity. Can be any direction. Okay, doesn't really specify. Pressure is a scalar quantity. Pressure. It's a scalar quantity. We list this one for displacement. Okay, scalar quantity. Work done is a scalar quantity. Power is work done. Power is a scalar quantity. Power is a scalar quantity. Mass is a scalar quantity. Mass is a scalar quantity. Mass is a scalar quantity. But if you want to make comparison to mass, you know the one that's similar to, for vector, the similarity here is what? Weight. Okay, for mass. For vector is the weight. Weight has a direction. Weight is always acting downwards towards the center of the earth. So now let's measure the vector quantity. You can say momentum is a scalar quantity. You can add momentum here. Momentum is a scalar quantity. So please familiarize yourself with these things there in exam paper. Familiarize what is a scalar quantity. A scalar quantity is a quantity that has magnitude only, and they do not have direction. Vector quantities are those quantities that has both magnitude and direction. Now let's give example. More example here. Yeah, we already mentioned velocity. Velocity as a vector, displacement as a vector, acceleration is a vector quantity, because here you tell the direction the object is going. Acceleration is a vector quantity. Force is a vector quantity. Force is a vector quantity. Moment is a vector quantity. You remember moment is force times perpendicular distance. It's about rotation, clockwise rotation, anti-clockwise rotation. So moment is a vector quantity because it has something to do with direction. Moment, not momentum, okay? Momentum is scalar, but moment is a vector quantity. Okay, so there are more. Anyone we remember we mentioned. Okay, moment is a vector quantity. Work, energy, and power, they are all in scalar quantity. And then which other quantity that we are very familiar with? Anything, light is a vector quantity because it moves in a straight line, right? Anything that moves in a straight line already has a direction. It's a vector quantity. Okay. So these are some examples. If you remember more, we put them, okay, but you need to understand velocity, displacement, acceleration, force, moment, light, all these ones, weight, they are all vector quantities. So for today's class, I think we call it a day, okay? We call it a day. Thank you for joining us. Thank you for joining us in our today's class. Okay, thank you for joining us.